Okay, now the recording is on. So we talked about, all of these concepts, Java, J2E, Spring, Hibernate, various concepts. We talked about servlets, API. Next, before that, we talked about JDBC. It's an interface as well. And then, as I told you in the beginning, first couple of classes, I told you that the word interface, I use this hundreds of times. So as I told you, JDBC is an interface that helps you communicate with the databases in a seamless fashion without having to worry about the low-level details about connecting to these databases. So for that, we have got JDBC interface, which gets implemented by the JDBC drivers, which in turn which are provided by the database vendors themselves. And then we looked at servlets. So servlets again is an interface that helps you write web-based applications that are web server agnostic or servlet engine agnostic, meaning if you follow servlet spec, if you use servlet spec for your web applications, if you do exactly like how servlet spec says, deploy it. If you build the application like how servlet spec says, then your web application is portable across multiple web servers. You can deploy this web application in Tomcat, you can deploy this in Jetty, you can deploy this in WebSphere, WebLogic, so on and so forth. Same case with JDBC earlier. So you can talk to Oracle, Microsoft SQL Server, Informix, DB2, anything seamlessly. JDBC helps you with that. You don't have to change code for that. So, and we talked about JPA because we have a lot of persistence providers. So we have Hibernate, we have TopLink, we have Eclipse Link. So we have multiple persistence providers, and we wanted to standardize. We need a common API, a common interface to talk to these persistence providers. So if I have a standard API, then I don't have to write to the implementation. I don't have to use Hibernate API. Rather, I use JPA, Java Persistence API, and behind the scenes, of course, the work will be done by the actual implementation, which is Hibernate Persistence Provider. But switching between persistence providers. So if I write JPA code, it's portable across multiple persistence providers. So if you change from TopLink to Hibernate for some reason, switches should be a breeze because you wrote all of your code in JPA, which is persistence provider agnostic. So we talked about all of this, an interface, beautiful. Whatever we talked is on one side, and whatever we are going to talk about, the concepts that we are going to learn today are on the other side. It's not mainly about the web applications that you have been dealing with for the last couple of months. So it's not the single application. All these while you are heading down and then writing, making your web application as scalable as possible and as maintainable as possible, so on and so forth. But today, you're talking about integration between the applications. So you have an application here. and then you have another application here. So how can we have these applications talk to each other is nothing but the integration between these applications. So how can I integrate these two applications? So for example, I'll tell you, I've been taking this Amazon example. I'll take the same example. So we have Amazon transaction processing. Okay. So we have big Amazon database, and we have this Amazon middleware. Okay. About the architecture that they have for the last, I don't know, several years, probably 15 years. So maybe because of their volume or whatsoever, they're using some technology here. Okay. Or maybe they bought another company and they acquired their middleware architecture. Maybe they have mainframe here, a big fat mainframe that's a very old application. Okay. In this example, Amazon is pretty new, but take any other example of take any of the big banks like a Chase. Okay. Chase or Bank of America, you think of their middleware, the core functionality, the core systems that they have. They have the databases here, and these are the core systems. They have a payment processing system that probably they have been using for well over 40 years. This could very well be mainframe, payment processing, claim systems. They already have it. Now, if you go to chase.com on the website, they may have 15 years back, they may have some very old chase.com website or bankofamerica.com website. Okay. Now, the web technology has changed so much. So many things have changed on the front end. So we have got the JavaScript libraries and JavaScript MVC frameworks, and HTML5. Before HTML5 there was Flash, and so many technologies kept on changing. So they were changing the front end. They were changing the front end. Obviously, everybody has to embrace the change, and they have to make it more usable to the customers, right? They can't say that, yeah, I've been using this whole the whole website for the last 20 years. Yeah, we can't change it. You have to embrace the change. You have to go with the flow. Make customers happy. So your end customers go here. This is your web layer, and then you can change it. So you are, but keep in mind, this whole thing constitutes Chase, right? Your web layer, your middleware and your database, everything constitutes, this whole thing is Chase. So if you need to change chase.com, if you want to move from one technology to another technology just because it's not being supported anymore, our users don't like it, it's very old technology, let's migrate them, we can't find the developers for this one anymore. So when we change it, you don't have to change the entire infrastructure, entire systems, because on the middle And the middleware end, they have the systems that they have been using for the last 20, 30 years, and they work very, very, very well. There is no need to change all of this. But your front end, because this is what is customer facing website. So this needs to be changed, absolutely. So you have the bleeding edge technology on one end, but you have this 20, 30 years of core systems on the other end. And there is no reason to change this unless you have a pressing reason, re-architecture, this whole thing. If you want to do it, yeah, that takes around 5-6 years project, at least. But there's no reason to change it. And billions of dollars, I'm not billions, but hundreds of millions of dollars worth the projects probably. So there's no reason to change it. It works perfectly, and this is the right thing to do it, and there's no reason to change it. But on the other hand, we can embrace the new technology, and we can be as customer friendly as possible, everything. But when we have the systems like this, and we have another system, Chase bought some other company, like a Bank One. This is Bank One. If you remember this company called Bank One, the bank called Bank One, it's a Midwest-based bank. They bought it back in 2006, I believe. So with this merger, they got Bank One's infrastructure, Bank One systems and everything. And their technology stack is entirely different. But they want to keep this core system here, the claim processing or statement processing system or whatsoever. But these systems are going to coexist too. These systems have to coexist, and these have to talk to each other, right? It's not that, okay, let's shut down and then let's do it from tomorrow. We are going to be using this system. Or you shut down this one, you switch it off and switch on here. No. These two systems have to coexist in parallel for at least, I don't know, several years. So these have to talk to each other, and data has to flow between these, and functionality. This system may have one particular piece that excels. So this guy may want to use that functionality, and they have some claim statement processing that they've been using for 30 years and works absolutely perfectly, and this system may want to use this one. So you want to transfer the data between these two, and similarly here, we need to marry them together. They are entirely discrete systems. This is written in some COBOL 30 years back, okay, and some of these systems were written in Python recently, and these systems were here. These were written in Java and Scala and other technologies. So when we have this heterogeneous environment like this, so how can we have these systems talk to each other, and how can I send the data? Well, when we talked about the web services, we talked about the similar heterogeneous system. And then for interoperability, we used to use Corba. It's a proprietary protocol, and later we started using HTTP. And SOAP over HTTP was with SOAP-based web services, and later on we realized that SOAP ceremony is not required, and let's use plain HTTP. True, HTTP can be used. Still, there are so many services that are exposed as web services. But that's not silver bullet. That's not for everything. Unfortunately, HTTP lacks the reliability if the server is down. I want to send some data to this system, I want to be able to send to someone, and that someone, the middleman here, if this system is down, this guy has to keep this information in its own database. And then whenever this guy wakes up, he has to give me. But that's not the case with HTTP. You have to retry it on your end. This is client's responsibility. So to integrate these systems, and in fact, HTTP, web services, and RESTful, these came into picture recently. These are hardly 7, 8 year or 10 years old technologies. But we have these systems for the last several years. We have been living with this discrete systems, heterogeneous environment. So if you want to integrate these heterogeneous systems, we have been using the messaging architecture. The messaging architecture. What exactly is a messaging architecture? Well, messaging architecture revolves around something called message. A message is nothing but a payload or data that gets sent from one application to another application. And the message gets passed from one application to another application without having to know who the recipient of that is. That is the beauty. So between these two systems, if I want to send some information from here to here, this system to this system, I don't know anything about this system. I have no idea about what the technologies are being used, what's the protocols, what is the semantics here. I have no clue. But I send a message to someone in between. This someone is called message-oriented middleware. Message-oriented middleware. And it's called, in short, it's called MOM, M-O-M, message-oriented middleware. What it does is, it does the brokering between these two systems. So what exactly happens is, you have one application here or one system here. You have one bank one payment system. And you have Chase statement processing. So they collected the payment and they have to send to the all of this information to Chase statement processing system, because this system has been working very well for over 30, 40 years. So there's no reason to change it, and they want to use it. Okay. So they have another system that they have been using, some vendor, and they said, because of the merger, we have the better technology. Let's use this guy, Chase statement processing system. So obviously this guy has to send some data. That data will be sent as a message to someone, a broker here. This broker is called message-oriented middleware, to someone. This guy has no clue that the statement processing system here, someone will get the message and then will process on it. This guy has no clue about the receiving end. All it knows is there is someone that's brokering between me and other applications, and I don't have to know about this. This is completely decoupled architecture. That's the beauty about messaging. This is completely decoupled architecture. I have no idea about this one. I will send a message to this guy, And this is a message-oriented middleware, a kind of software. Okay, this has been existing. This has been exist for the last 30 years as well. Message-oriented middlewares. There are a couple of moms that have been in the market for the last 35 years. They take the message, whatever the format that they send it, they will store it internally in their databases. And then whoever is interested in receiving the message will register with this guy. They will register. Okay, I'll register. Say this system will register here. Say that, hi mom, I'm message-oriented middleware. I'm interested in receiving these messages, and these messages will be sent within this message-oriented middleware. There are some virtual channels called destinations. These are called destinations. This is like a channel. Okay, I'll just send a message. This is like a mailbox. Okay, since we're talking about the mailbox, let me give you this example. So we have two people here. Geeta wants to send a message, a mail to Sunita. Okay, and she will post a message, the message box, right? So one guy, one broker, someone will take the message. Okay, she'll put a message and then write it. Okay, this has to go to this mailbox. She has no clue about the receiver also. In fact, she'll say that, hey, I'm sending a mail to this mailbox. Here there is a mailbox. Here there is a mailbox. I'm sending a mailbox to mailbox number 5333. So whoever is interested in those messages, so Sunita will say that, hey, I'm interested in receiving all the mails that are coming to the mailbox 5333. I'm registering myself as a consumer of these messages. So another term here is she's a producer of the message. She's producing the message and posting the message into the mailbox. And then Sunita is registering herself to that mailbox saying that, hey, every time you get the message here, can you please deliver it to my house? Absolutely. So as soon as the message is here within this mailbox, so someone will go and deliver it. That message will be sent to Sunita. And she has no clue about Sunita, and so Sunita has no clue about the sender. Both of them know about this message-oriented middleware and especially this virtual channel called destination. We'll talk about the specifics about the destinations. There are two kinds of destinations, but that's what it is. The mailbox, it's nothing but the mailbox. Destination is nothing but the mailbox. So she will put a message there, and then this guy's responsibility is deliver the message to whoever registers it. The beauty here is Sunita is not interested in listening to this. Okay, I said listening. That's another technical jargon here. She doesn't want to listen to the messages on this particular destination. So she deregisters. She'll say that, hey, I'm not interested in receiving the mails anymore. Okay, then someone else comes in. She has no clue about Sunita. She only knows about this message-oriented middleware and the mailbox number 533. Now someone else came, Rajani. And Rajani says, hey, I'm interested in receiving these messages. Can you send it to me? Absolutely. And now these messages will be delivered to Rajani. Does he have to change anything? No. She just deregisters herself and someone else registered, and then absolutely message-oriented middleware's it is message-oriented middleware's responsibility to send the message to whoever registers, whoever is interested in the messages that are coming into this mailbox. Simple. What do we get here? These two discrete systems that are written in completely different programming languages, completely different infrastructure, completely different protocols, everything. They're able to communicate now. This guy is able to send and this guy is able to receive it. Well, the another beauty is this message-oriented middleware guarantees the delivery. If this guy, if Sunita is not available, if she deregistered herself, right? If Rajani is not available here, if she's gone on vacation for a couple of days, it will store it. And as soon as she comes back, the message will be delivered. So guarantees delivery. And the another one is, the another interesting terminology here is, I'm not waiting for someone to receive the messages. If I have to send a straightforward message, this person to person 1 to person 2, if I have to send a straightforward message here, then if I have to send a big payload, then I have to wait until this guy receives it. If he's not available, then I'm in trouble. Then I have to write some logic here. What should I do? Then again, I have to keep trying. You don't worry about it. In fact, you have no clue about the receiver. Senders and receivers do not know about each other. Now, here, this mailbox 5333, right? Now, Geeta is not sending the messages to this mailbox anymore. Someone else is sending. Does anything change here? No. Senders and receivers, these are called clients actually. Senders and receivers can be added without anyone getting affected. And then here person one is not waiting until the message is completely consumed by person 2. So if I make a call, if I call a Java program, right? If a Java program, this Java program calls the another Java program, if this guy takes 5 minutes, I'm waiting for all the 5 minutes. This thread is waiting, right? I'm calling this guy and I have to wait until this guy finishes and then I can do my next step. This is called synchronous. This is synchronous communication, meaning I'm waiting until I ask him to do something. I asked him to do something and he's doing it and I cannot skip. I have to wait until the message is completely consumed and does his job and finishes his work, and then only I can do the next step, whatever the next step is. This is called synchronous. But here, no. Paradigm is different here. This is called asynchronous. In asynchronous mechanism, what happens is you have this simple philosophy called fire and forget. You post a message, you fire a message. You post a message and forget about it. Forget about who receives it and what he does upon receiving it and how long he's going to take it. That's not your business. You completely decouple and you keep on proceeding as if the work had been done. Because message-oriented middleware is going to provide you the guaranteed delivery, and upon receiving that particular message by one of these receivers, they will do their job, and it's their responsibility now. It's not your responsibility. Your responsibility is to tell them that, hey, can you do this statement processing? Can you send? All I have to do is, hey, this guy paid the payment. Can you send him the statement? That's all I wanted to do it. The generating the statement, printing the statement, putting them in snail mail and sending them through email, all of this is responsibility of this whole system. All I have to do from my end is I just have to post a message that you do your job. Hey, this guy paid for this month, credit card payment has been made, and then can you send the statement? That's all I wanted to say. And this guy will take care of everything. And am I waiting until all of this happens? In a synchronous way, but what happens? Then I have to wait. Here you don't have to. You just post a message, and that message, guaranteed delivery. Through guaranteed delivery, that will be delivered to this guy, and this guy will do its job. So multiple systems that are written in completely different languages, completely different architectures, 30 years old technology with the bleeding edge technology. Because of this decoupling, they can talk to each other, and moreover, asynchronous communication, asynchronous messaging. That's the beauty. Fire and forget. You don't have to wait. You don't have to wait until he finishes. Let him take 2 days to finish it. Absolutely. My job is to tell him that, hey, you can kick off. I'm done. Yes, your next task can start. He paid for the credit card, and you can start processing your job. You can start your job. So this is a great architecture, and it's a great tool for architects and designers. If they have these discrete systems, they use this messaging to communicate, to pass the data between the systems, or to pass the functionality, or to tell other system to do something. And decoupling and asynchronous, it's a flexible architecture. It gives you very flexible architecture, so that this guy can, if you want to improve your system, you don't worry about all of these systems that are talking to you, because you have this message-oriented middleware. You improve this system independently of all of the systems. If you want to move from old Flex application to HTML5 here, if you want to use any of the fancy client-side JavaScript, JavaScript MVC libraries, absolutely go ahead and do it, because you are client-facing. But here, this is such a robust system, I don't have to change it, and I don't worry about it. So that gives you a lot of flexibility here. So as I told you about the destinations, we have two kinds of destinations here. Two kinds of architectures here. I mean, though I'm putting the human beings here, it's mainly the systems, right? So the system 1, application A, and application B. We have two kinds of destinations and two kinds of architecture. One is called P2P, point to point. One is called point to point, meaning I'll post a message. Whatever the message that I'm posting should be consumed by one and only one receiver. As soon as receiver receives this guy That's it. The message is gone from the queue. This destination is called, this mailbox is called queue. Destination is a more abstract term, and queue is a specific term for point-to-point architecture. In the case of point-to-point architecture, when a sender sends a message to the queue, receiver, only one and only one receiver will receive it. Maybe there are several receivers waiting to consume the message on the same queue, on a mailbox, on the same mailbox. You may have several queues, right? So this particular queue, I can give some name here, right? It's called statement processing queue. Statement processing queue. So this statement processing queue, I have several clients who are registered to this queue, statement processing queue. What they're saying is, hey, as soon as you get the message, as soon as we get the message, we'll take it. Okay, I'm interested in this message, I'll take it. Again, in the message sending from this destination to the message receiver, there are two ways again. One is polling. Polling is nothing but, you don't worry, you'll just keep the message with you. I will keep polling. Meaning, I'll keep looking. Every few seconds or every couple of minutes, I will go and check. Hey, it's like me going to the mailbox and say, someone will drop the message, and then me going every hour or every day and then say, hey, do I have any message? Did I get any message? That's my mailbox. That's what I do, right? That's what you guys do on a day-to-day basis. You just go to the mailbox. Did I get any mail? Did I get any mail? Did I get any mail? That's called polling. So you keep checking. The another one is pushing. This pushing is nothing but, as soon as the message comes here, that gets delivered to one of these receivers. But keep in mind, in the case of point-to-point, there can be several receivers that are registered to the queue, but this gets delivered to one and only one receiver. It could be polling. These guys may be polling, saying that, hey, do I have a message? Do I have a message? Or maybe this whole message-oriented middleware itself can push it. Okay, but generally, in a point-to-point case, these clients will poll for the messages. They will go to the queue and then clear the mailbox. They'll just consume the message. They just consume the message. So this guy is producing the message. A is producing the message, and B is consuming the message. C is also here. But unfortunately, he didn't get chance. Maybe next message will be taken by this guy. But only one consumer will consume the message on the queue, because queue is meant for point-to-point architecture. There will be one sender and one receiver. That's why it's one-to-one. P2P, this is also called point-to-point, is also called P2P or P number 2P. It's also called one-to-one. So one producer, one consumer. That's P2P architecture. There's one more. This is about the point-to-point architecture. There's one more architecture. This is called publish-subscribe. Publish-subscribe architecture. publish subscribe architecture. Here this destination is not called queue. This is called topic. This is called topic. Here there is only one sender. I'm sender. I'm sending the message. There is only one sender. But there could be several, 0 or more receivers. Receiver 1 or this is sender. Let's say sender. And here we'll say the subscriber. These are called subscribers. Subscriber. Subscriber. You can have as many subscribers as possible to a topic, and as soon as the message is received, the message will be pushed. Mostly in the publish subscribe model, it will be pushed. The message will be automatically pushed to whoever is listening, whoever is actually subscribed. That's what they call it. Whoever is subscribed to this topic will be, the message will be pushed to all these clients or subscribers. If you are subscribed to Time magazine, as soon as the new edition is released, that will be delivered to your house, right? And there could be millions of subscribers, and they will publish it. The sender here is called publisher. This guy is called publisher. That is why it's called publish, subscribe. There will be one publisher who publishes the message, who also called broadcast the message. Because I'm broadcasting the message, and this will be delivered to all the subscribers who are subscribed to this topic. The beauty in both P2P and publish subscribe model is you can add the new subscribers or you can delete the new subscribers. You can anytime you can deregister it. You can say that, hey, I don't need Time magazine anymore. I don't want it. Or a new guy comes in, hey, I want it. I'm a subscriber. Can you please push me too? Absolutely. As soon as the new one comes and now you are the new guy, it knows at any point, hey, how many subscribers do I have? Oh, I have these million subscribers. Sure, let me push this new magazine to all these 1 million people. And the same case here. It'll be pushed. It'll be generally polled. I'm not saying that it's not possible to be pushed. It can be, but general technique I'm saying. Generally, these people will poll or it can be pushed too. But either polling or pushing, there will be only one consumer. There will be only one consumer. But the beauty is completely decoupling. At any point, you can drop yourself as a consumer. You can say that, you know what, I'm not interested in receiving these mails anymore. And then another guy, D, comes and says, hey, I'm interested in receiving mail. Can you please push me, or I'll keep polling. But there will be, this message will be sent, delivered, or this guy will be polled to only one receiver. And then the message is gone completely. But here, the copy, in the publish subscribe model, a copy of the message will be pushed to all the subscribers. That is publish subscribe model. And this is the messaging model. This is the messaging architecture. All these big companies, every single big company out there uses this messaging architecture, because I'm sure they have, it's impossible to have one single system. Even if they have a single system, maybe they have vendors who are on a different platform. At least in that case, you would need this messaging architecture. You may want to send the message. And these message-oriented middlewares, they broker between these senders and receivers or publishers and subscribers. These message-oriented middlewares, they have been exist for a long, long time. And some examples that dominate the industry are IBM, WebSphere, MQ. IBM WebSphere MQ exists for the last several years, and Microsoft Message Queuing, MSMQ, this exists for the long time, and Sonic MQ, and several others. There is one open source one called Apache Active MQ. Apache Active MQ, IBM WebSphere MQ, Microsoft Message Queuing, Sonic MQ, Active MQ, to name a few. And these will broker between these senders and receivers, publishers and subscribers, and they don't care about, this is message-oriented middleware. They don't care about the underlying architecture. Typically they support several programming languages too. They'll give different APIs to talk to this message-oriented middlewares. Generally, these message-oriented middlewares of all these people, they have their own API for clients to send a message and for clients to receive a message. They have their own API. IBM WebSphere MQ, they have their own API. MSMQ, definitely they have their own API. They have their own API. They have their own API. But pretty much, it's the same, right? It's like talking to database. It's the same standard stuff. You may want to behind the scenes, pretty much the same thing. You may want to open the TCP/IP socket. You open the connection. Once you open the connection, I'll send you a message in a particular format. I can send any message. This guy doesn't care about it. I can send a message and then close the connection. So it's very similar. There are some, of course, some of these vendors can do much more than the other vendors. But there is some similarity between, similarities among all the APIs that they expose to these applications. So for the Java world, what Sun Microsystem, all it does is standardizing. They said that, hey, you know what? Rather than writing directly to this IBM WebSphere MQ API, maybe it's a good idea to have one more contract that sits on top of all of these message-oriented middleware APIs, so that these clients, it doesn't matter whether you're sending or receiving, these clients will not have to talk in the proprietary API of IBM WebSphere MQ or MSMQ or Sonic MQ or something. Rather, let's have these clients use a standard interface. That's called JMS, Java Message Service. I'll provide a standard API and then let them use JMS. And if these vendors provide the implementation for JMS, then these people use JMS. This guy used JMS to post a message to this QR topic, and this guy will poll the message, or it will be pushed to this guy using again JMS. And what's the benefit? It's exactly like JMS. It's exactly like JPI. It's exactly like JDBC. It's exactly like Servlet. It's the same thing. It's portable across all of these MOMs, message-oriented middlewares. If you change from WebSphere MQ to Sonic MQ tomorrow, if both of them support JMS, then you don't have to worry because you coded to interface. Behind the scenes, with a simple switch, like how we have in JPA we have the persistence.xml. Similarly here you'll have some simple switch. You change it, everything works because you are using standard API. You are not using the vendor specific API. That's how JDBC came into picture. That's how Servlet came into picture. That's how JPA came into picture. That's how JMS came into picture. All of these are interfaces. If you look at it, they'll make you portable across these vendor systems. Here, they'll make you portable across multiple databases, and here it will make you portable across multiple persistence providers. Here it will make you portable across multiple message-oriented middlewares. In fact, Servlet Spec is the same thing, no exception. It will make you portable across multiple web servers. Same thing. Bunch of interfaces have been provided, like how JDBC API is provided, JMS has been provided. That's it. You use JMS and then post a message, receive a message. Simple. And then when you change but who will do the actual nasty job of actually sending the message, or delivering the message, or receiving the message and storing it in, making it durable message? Who is doing the actual work? These message-oriented middlewares. This guy just provides an API. That's it. A standard way for these clients to communicate with the message-oriented middleware so that it will be portable across multiple MOMs. Very simple. That's it. These are all popular interview questions too. I mean, if someone asks about JMS, it's good to know about P2P, publish subscribe. Here the destination is queue. Here the destination is topic. Here it's one-to-one, one sender, one receiver, one sender, multiple receivers. These receivers are called subscribers. The sender is called publisher. Here it's called sender, it's called receiver. One sender, one receiver. So that's it. And before we look at the example, I need to tell you a couple more things. Okay, how do we use JMS? So what is JMS API? How do I use JMS API to post a message to the queue or topic? Okay, let's talk about posting a message. How do I do that? So if you want to post a message, first of all, your client application, your Java application needs to open a connection to this message-oriented middleware, right? If you're talking about the queue connection, so if you're talking about the queue here as the channel, as a destination, then you need to open up the low-level TCP/IP connection. And obviously, these connections can be pulled, like how the database connections are pulled. So these connections can be pulled. Okay. So there can be one singleton factory that can give me the connection to connect to this message-oriented middleware. Right? So there is an interface called Queue Connection Factory. Queue Connection Factory will give you connections like your driver manager.get connection or data source.get connection. It's very, very similar to the JDBC API. Queue Connection Factory will give you handle to queue connection. We're talking about queue here, queue connection. Once you get the connection, Now connection is established. It's similar to JDBC connection. Once you get the JDBC connection, if you want to send something, you need statement. Connection that creates statement or connection that prepares statement. Here, you need to open up a session between you and the message-oriented middleware. That is called queue session. So once you get the connection, you can say create session and then create queue session, and then you'll get the queue session. So once you get the queue session, now you can be a sender or you can be a receiver. So from session, you can get either a sender, which will help you send the message, or receiver, which will help you poll. Receiver is nothing but the polling. You poll the queue for any new messages. So this guy will have a receive. That's it. No? We need to somehow tell that, hey, there are 100 queues in this message-oriented middleware. I am talking about this particular queue, the statement processing queue. Can you help me? Absolutely. So there is one more interface called queue, javax.jms.queue. So here, this holds all the details about what queue are you talking about, what is the queue name, and the other details about the queue. So once you post the message, once the sender sends the message, it will send the message to this queue. And there is an interface called message itself. And there are several kinds of messages, object message, text message, and all that stuff. And if you want to send some simple ASCII, simple text, then use this specific class called text message. So use this text message, a class called text message, and create a new text message and then send it using the sender. And your queue connection factory, queue, these are all linked. So that when you post a message or when you send a message, then the message will be sent to this particular queue. This is about the posting. How about the receiving? It's exact same thing. If I want to write a piece of code to receive the message on this particular queue, it's exact same thing. In factory, because I need to establish connection with this guy, right? So I need to establish connection, queue connection factory. I need queue connection. Again, the queue session. And again, you can be either sender or receiver. Here in this case, you'll be receiver. Once you say that receive, you will write, you'll call the receive method and you'll get the message if there is any message, and then it will give you the message. And you open up the message. If the type is a text message or whatever the message that you're looking for, you open up, read the message, and do whatever you need to do it. Maybe you need to print the statements here for credit card statements, like in the earlier example. Go ahead and do it. And this is for queue. An exact same API. You have one more set of interfaces for topic. Topic connection factory, topic connection, topic session, publisher and subscriber. Publisher will do publish. Subscriber will subscribe. Okay, now let's talk about, this is about sending and receiving on the queue side, right? Now let's talk about asynchronously receiving the messages from queue or topic. Meaning, I don't want to poll. I don't want to go to mailbox and say, did I get a message? Did I get some message? I don't want to say that. Rather, when you get a message, you deliver it to me. So you have your message-oriented middleware here. And this guy I'm talking about publish subscribe model, but it works exactly for queue model too. So here publisher published a message, and here we are talking about a topic here. This guy posted a message. Okay, now I have a subscriber here. I have several subscribers. I'll get a copy of each message, right? I'll have a subscriber here. Okay, so on this side, I have to open up, I'll have to open up the connection, and then one is keep polling. I don't want to poll it. The other thing is you just stay here. Okay. As soon as the message comes here, the message will be delivered to you. What do you mean by that? How does it happen? Well, what happens is there is a standard interface in JMS called message listener. javax.jms.message-listener, there is an interface called message listener. So you implement that message listener. I'm going to say statement processing subscriber. Okay. So this guy subscribed to this particular queue. I'll say implements. So somewhere I will say that, hey, I'll keep the connection open, and then statement processing subscriber. This guy is the message listener. I'll say that this particular class is the message listener. Then if you are a message listener, you have to implement javax.jms.message listener. Message listener has a method called onMessage. And then this gives me the message, whatever the message that one is. This one has a method called onMessage, public void, I believe. Yeah, it's void. OnMessage. You know what happens? As soon as the message, this guy, as soon as the message is posted here, published here, this guy will realize that, hey, there is a listener here. He's listening to me. Oh, statement processing subscriber is a class. Okay, this guy is a message listener. Then I have to call the onMessage. Then this guy will call the onMessage. This guy will call onMessage as soon as the message is arrived on this particular topic. These are called message listeners. If you are implementing a message listener in JMS, then your class has to implement message listener, and you have to implement the onMessage, and you do whatever you need to do it. You open up the message and read it, and then say, oh, this guy, this particular customer has already paid credit card balance of $1,500 for this particular month. Okay, these are the details about the customers. Okay, I need to start processing the statement. Absolutely, I'll do it. So here you are not polling. You're not every few seconds you wake up and say, hey, did I get any message? Did I get any message? No. There will be a dedicated connection open between you and this guy, the topic. And then you'll just keep listening. Please drop me a message as soon as you get it. As soon as you get it, the message will be dropped to you. How? It will call the onMessage with the complete message payload. The whole message will be sent to you as an argument here, and you do whatever you need to do it. That's how it works. That's it. That's about the message listener. This is an asynchronous way. So you don't keep polling. Rather, it will be delivered. You don't worry about it. I'll let you know when when I get the message. As soon as I get the message, I'll knock your door. I'll call you on message and give you the message, and you do whatever you need to do it. So these are about JMS concepts, JMS API, messaging concepts. We talked about messaging concepts, why we need them, the architectural style, asynchronous processing, and then we talked about JMS API, why we need JMS API, and all that fancy stuff. And then how do we do it? How can I post a message? How can I receive a message and everything? Now, for the examples, IBM WebSphere MQ is the top-notch, is the most popular MQ engine or message-oriented middleware out there. But it's extremely hard for us to show and configure it. Installation pretty big, pretty big deal. Okay, so I have taken the Apache ActiveMQ. It's very similar Apache ActiveMQ. So go to Apache ActiveMQ site and then download Apache ActiveMQ. .apache.org. This is a message-oriented middleware. This is open source. You can download free. You can contribute. You can play with it. Absolutely, you can do it. And then you go ahead and download. I already downloaded. So you can download. So you can download the latest version. I downloaded already and installed here. Our training environment Apache ActiveMQ 5.5.1. Obviously, that's the may not be the latest one, but you can go ahead and get the latest one itself. Okay, and then go to bin and then click on this MQ ActiveMQ.bat. Now you are starting the ActiveMQ server. You are starting the message-oriented middleware. So this will be listening on a particular protocol. I'll show you the example. A second. See here, if you want to take a look at the HTTP, there is a website too. See this? So go to 8161/admin. Instead of 00, it's actually localhost. So go to localhost:8161/admin. This is ActiveMQ admin page. You installed ActiveMQ, you are running ActiveMQ server, and now you went to the admin screen here. Okay, and here see this queues, topics, subscribers, connections. Click on queues. You have 3 queues here: test queue, test queue1, test queue2. You can delete it, you can delete it. You can delete the test queue. You can leave it. You can, if you want to create a new queue, absolutely. Whatever that one is, we're talking about the statement processing, right? If we think that statement processing generally is going to be done by one particular receiver, it's not like a broadcasting, right? It's not like a broadcasting. Examples for publish subscribe model is I myself did this project back in 2001 when I was in Malaysia. I worked for a bank there, and I was on a project that integrates two particular systems of the bank, unit trust and asset management systems of a bank. We have this, especially the asset management part. Asset management. If you don't know asset management, all these who have at least, I think, minimum of 500,000 ringgits in Malaysia. If you have that much money, then you don't want to play all that money with the stocks and other categories, right? Stocks, debentures, and whatsoever. If you want to keep it in equity and all that stuff. Again, if you want to put it in stocks, where do you want to put it? It's a big game. You don't want to play with that big amount, right? That's why you will either put it in mutual funds or something similar. Have that big money, what they do is they will assign you a dedicated fund manager, and then they will invest your money into various sectors. Some of them in stocks, some of them in equity. They will leave as equity. Some they will buy bonds, and based on your interest, they'll take all of your input, and based on your interest, they'll do it. So it's that kind of company. That's an asset management company. That's what they call it anywhere in the world. So you have so many asset management companies. So many banks have that asset management divisions, and all of them, they invested heavily in stocks. So obviously the stock ticking, every second is important here. We want to observe this, how the stocks are doing. Okay, these particular stocks that I'm interested in. So, for example, Microsoft, MSFT, $23, IBM, Apple, whatever. Okay. So this is Kuala Lumpur Stock Exchange. This is Kuala Lumpur Stock Exchange. At that point, they opened up a channel here, a topic here, and they post a message to this particular queue as soon as a particular symbol, this is called symbol, the stock code, as soon as a company's stock price changes. If it changes from 23 to 23.50 in 5 minutes, then they'll post a message saying that, hey, Microsoft has changed from 23 to 23.50. And all these company asset management, these depend heavily on the stock price within that second. They don't want to wait anymore. So as soon as the message is posted, it has to broadcast. It will broadcast this message to all these asset management companies, all these banks. Say that, hey, this is the new stock price of this Microsoft. This is the new stock price of IBM. This is the new stock price of Apple. It will broadcast the message. This is a typical use case for broadcast. Publish, subscribe. They'll just publish a message and all the subscribers will get the message. And whatever they need to do it, they'll do it. They'll post a message to fund manager, or they'll trigger something on their systems, whatever they need to do it. And then if it fluctuates too much, fund manager, they will sell the stock, buy the stock, everything. Okay. So that's been typical example for publish subscribe model. So this is an open source message oriented middleware ActiveMQ. These are all the queues. You can have a queue here. Yeah, the point I was making earlier is typically the statement processing is not broadcasting a message. You'll not have 100 subscribers who are subscribed. You'll not even have more than one for that matter. That's why it makes sense to design this as a queue, not as a topic. But something like this, topic, you can definitely have it. You can have another topic. You can say that stock ticker topic. As soon as the stock changes, it will post a message there. Okay. So that's it. This is how you can create a queue. You can create a subscriber. And then obviously if you want to use JMS, initially you need the queue connection factory and a queue. So traditionally, let me step back and I want to make another point. I told you about so many MQs there, right? WebSpeed MQ, Sonic MQ, Active MQ, and MSMQ, and all these dedicated MQ, MSS-oriented middlewares. But what I wanted to tell you is all these big servers like EJB containers, so-called application servers like a WebLogic, WebSphere, for that matter JBoss too, though it's very lightweight in nature. All of these application servers, they come with inbuilt JMS engine already. You don't have to buy or you don't have to use another one. They already ship the JMS engine inbuilt into it. So you have this big WebLogic server or WebSphere server. So within this WebSphere or WebLogic, it's definitely up to you to go ahead and use a separate message-oriented middleware. But if you use any of these application servers, it by default comes with the web container, right? It comes with Tomcat already. By default, it comes with the web container. It can take HTTP requests. This is a web. And by default, it comes with EJB container too. And by default, it comes with the JPA persistence provider too. Most of them. Persistence provider too. That's why it's a package. Application server gives you everything. It comes with the default web engine, default EJB server, persistence provider, and then JMS too. JMS engine. It may not be as robust as a standalone WebSphere MQ or Microsoft MQ message queuing, but definitely not bad JMS engine will be shipped along with your application server. You can use it. For all these services, right? If you have some administrable objects, if you have a topic or queue, okay, that's defined here in the JMS, WebSphere JMS or WebLogic JMS engine. If you want to get handle to that queue or topic, or if you want to get handle to that queue connection factory or topic connection factory, because you need connections, right? This whole application uses something called JNDI, Java Naming and Directory Interface. It is again another interface. Using JNDI, it will store all of these details in somewhere in the server, and when you give the associated JNDI name, every one of them will be associated. All of these objects will be associated with a name, unique name called JNDI name. So you give the JNDI name, I'll give you the topic. So you don't have to use this stock ticker topic. You can change this guy, but you give a public name called JNDI name. Everyone, if you need this topic, if you want to get handled to this topic, then give me the JNDI name, then I'll give you this topic. Or if you want to post a message, you need connection, right? So topic connection factory, you need handle to topic connection factory and queue connection factory. Those are given to the application through JNDI also. You give the JNDI name and I'll give you the appropriate queue connection factory or topic connection factory. These are generally called administrable objects. Using JNDI, I'll give you. You give the JNDI name, I'll give you the appropriate queue or topic. So I just wanted to let you know. And the same principle is applicable for EJBs also. You give the JNDI name, I'll give you the associated EJB home interface. Then home.create will give you the remote interface and all that stuff. But this is before EJB 3.0 came into picture, where there is no concept of home interface. That's a different story. And again, the same concept is applicable. By the way, all of these application servers, they come up with their own connection pooling too, typically. Set up services. You'll get all of this as a package, connection pooling too. You will get a pooled connection from data source. That data source is also an administrable object through JNDI. You configure your data source. You configure your data source and you give a JNDI name. All you have to do in your application is you give the JNDI name, I'll give you the data source implementation. So I'm asking, this is all before injection came into picture, right, through Spring. So uses something called JNDI. But even Spring works very well with JNDI actually. The beauty of this JNDI is your code is not worrying about any of the stuff that your admin will only know. You're not worrying about the actual queue name, actual topic name, or actual connection details, and what protocol, what is port number it's listening on. You don't have to worry about any of those details. All those details, you just give all those details on a WebSphere admin console or WebLogic admin console, and you give a simple JNDI name. And anywhere in the Java application, you just give, hey, this is my JNDI name, can you give me the connection? Can you give me the data source associated with that? Or can you give me the queue connection factory? Can you give me the topic connection factory? Can you give me the EJB home interface? Can you give me any administrable object works that way? Give you 2 minutes introduction to JNDI. In fact, I gave when we talked about EJBs. Anyways, I will, earlier when we talked about the JMS API, I talked about the queue connection factory, topic connection factory, and then you get the topic session, queue session, and then you get the publisher, subscriber, sender, receiver, and everything. I told you. But what is the goal of Spring's framework? Spring's framework is to make Java development easier. I don't want to go through all of this JDBC. JDBC, you have to write 10 steps. All of this will be replaced by simple JDBC template. And you can write just one line of code. All the mundane stuff, opening the connection, closing the connection, everything will be taken by this template method pattern using JDBC template. Here also you are writing the boilerplate code. You're getting the queue connection factory, and then queue connection factory dot create queue connection. Once you get the queue connection, create session. Once you get the session dot sender or receiver, and then say receive a message, send a message. So sending a message and receiving a message, agree, that's a business logic. But everything else is boilerplate code. It's like a driver manager dot get connection, connection dot create statement, statement dot execute query once you get the result set, and again exception handling, try catch, SQL exception, and again in finally block, rs dot close, statement dot close, connection dot close, and unfortunately each one of them throw again SQL exception, which happens to be a checked exception. Boilerplate code. We don't want to write all of this. In fact, if we looked at JDBC code, 80% of the code was to satisfy the JDBC API. 20% of us was actually business logic. That's what happens most of the times. So Spring is here to eliminate all of that. So Spring wants to make our life easy with JMS too. So it provided a template called JMS template. Template takes care of everything. You just provide the details, you just give the queue details, and you just give the connection details. What connection are you talking about? So here we are talking about the ActiveMQ, right? So give what is the port number that it's listening on, what is the protocol that it's listening on, and what's the queue details. That's it. It takes care of all the low-level details. Spring takes care of it. So Spring has another template pattern. You have seen JDBC template, you have seen REST template, you have seen now we are seeing JMS template. So many templates. It's a simple template method pattern. Whatever you are doing again and again and again, automate it. Move that to a template method, and then only the stuff that's specific to your application, then call back. Call the interfaces method, and then you do the rest of the stuff. Anyways, so I'm showing you the example. I'm not showing you the traditional JMS approach with all the boilerplate. I think I'll show you that one too. But I'll show you with the JMS template. So message sender. So message sender, I have this at component, and then JMS template. It's like a JDBC template at auto-wired. It's going to be auto-wired automatically, and then I'm giving the queue. See this? This is javax.jms.queue. This is an interface. Whatever the queue that you are posting to. Then I have my own method. I have my own method called send message. So you give me the message, I'll post it to this particular queue. Okay. So I'm saying JMS template dot convert and send. There is a method called convert and send. You give me the queue. What queue do you want to post it to, and what message do you want to post it to? Is it this simple? No. Behind the scenes, it will create the queue connection factory. It will get the queue connection factory with all the details that you provided. Connection factory that create connection. Once you get that session, then publisher, in this case sender, receiver, and then it will send it. So you will write several lines of code, boilerplate code that you don't have to write. Using Spring template, that's it. All the queue details. But where would you give the queue details, and where would you give the JMS template details? What and all JMS template takes it? Where would you? This is the interface, right? But there has to be some implementation of queue. Absolutely. Let's take a look at our Spring config.xml. Okay. Component scan, base package com training, and this is my JMS template. I'm using org Spring framework JMS code JMS template. And then this one has a property called connection factory. What do you mean? Here it will call the set connection factory method on JMS template. And this is where we need to specify the appropriate connection factory. Here I provided the connection factory, MQ connection factory. This is a reference. Okay. So being ID equal MQ connection factory, class equal to, here I'm using org Apache ActiveMQ ActiveMQ connection factory. This is the ActiveMQ stuff. For that, you need to have all the ActiveMQ libraries in your class path. So you depend on ActiveMQ jar file, ActiveMQ jar file. See, I wanted ActiveMQ all 5.1.0. Okay, not a big deal. You can get the latest one too. So we have a connection factory from ActiveMQ called ActiveMQ connection factory. If you're moving from ActiveMQ to WebSpeedMQ, then use this WebSpeedMQ connection factory. And that connection factory, this particular ActiveMQ connection factory implementation has a method called setBrokerURL. This is where you have to specify what is your message broker URL, meaning this is like a JDBC URL. What protocol what port, and where is the server. This is what we did with JDBC. It's exact same thing. So where is the broker? Well, the broker we started. This is the broker. We started it. And then it's a TCP/IP protocol. And local host, the server is installed here. But if your MQ, if your active MQ server is installed somewhere, then you give the IP address of that particular server. Like your database. And this is your default port number for ActiveMQ 61616, like Oracle 1521, right? 1521 is Oracle, whatever the port. Yeah, 1521. So this is the queue connection factory, and I'm giving the queue connection factory to JMS template. Okay, this is good, but how about queue? You said queue, right? Queue gets auto-wired automatically. Okay, what implementation of queue? Let's talk about queue. See, this is the one, MQ send queue. Then I'm using again ActiveMQ queue class. This is another class by ActiveMQ. And then here there is this ActiveMQ class has a method called set physical name. So property name equal to physical name. So what is the actual queue name? So what is the actual queue name here? What is the actual queue name here? Statement processing queue. Statement processing queue. So this is the, if you have more than one queues, I'll say this one, statement processing queue. In your application, you may have several queues. Okay, so if you have several queues, then obviously this will fail because it gets getting auto-wired by type, and it will find lot of implementations. So in that case, you may want to do yet qualifier. So at qualifier, so I'm using at qualifier, so that even if I have one more bean here, Spring doesn't worry about it, and that's it. You don't worry about these beans, commenting them. All we are doing is we are just posting a message using JMS, especially the Spring version of JMS using JMS template. Okay. It's very straightforward. Now, let's write a test class, message sender test. So I'm using Spring JUnit 4 class runner, context configuration, so that my message sender will be auto-wired into my test class. I'm using Spring test. That's what in a nutshell. That's what I'm doing. And I have a method called test send. Okay. So here I have this code, but to start with, what we'll do, I have some fancy code there. We'll start test send. What we'll do is message sender dot send message. Let's send a message. Hello, it's time to process the statements for someone, John homeowner, or yeah, John credit card owner. Someone, okay? So we are sending a message. Let's test it. And what should happen now? It should post a message into this queue here, right? Currently, how many number of consumers? 0. Messages enqueued, messages dequeued. So how many messages it came into queue, and how many messages? As soon as that gets, as soon as the message gets received by a receiver, then this message will be gone, right? So let's take a look at it. Let's refresh it. It's still 0. Let's run this guy. Run as unit test. Okay, it's sending the message. Let's refresh it. See this? Statement processing queue. Message unqueued. Very good. And then message dequeued, meaning how many messages have been deleted from queue is what dequeued. Nothing. 0. But there is one in queue. Let's browse it. In queue, the another difference between queue and topic is in queue you can browse the messages. Before you consume the message, it gives you flexibility to browse the message and see if you want to consume it or not. You can browse it. That happens only in queue. In topic, that doesn't happen. The reason is, in topic anyway, you'll get the copy of it, right? The message doesn't get deleted on the topic as soon as it's been broadcasted. So you'll get the copy anyway, not the actual message, but here the actual message itself gets delivered. So you can browse it using this admin console. Go to browse. Oh, this is it got from Hari PC 63907 something. Let's click on it. Timestamp is just now 2016-08. Let's click on this one. The destination is queue : statement processing queue, and the message ID. This is the message ID, unique identifier. Persistence is persistent. It will keep priority 4. Redelivered false. Sure. There is no reply to sequence. Okay. Timestamp. What is the message details? Hello. It's time to process the statement for John, credit card owner. Whatever the message that we posted, it came to the queue. It's waiting. It's waiting there in the queue. See this? There's no receiver for this guy. Doesn't matter. It will keep it. Don't worry about it. Your job is done. All you said is, okay, someone, it's time to process the credit card statement for this guy. Sure, I got the message. Meaning, message-oriented middleware got it. ActiveMQ got the message and stored it, and now it will wait for the receiver. Receiver can register, can deregister at any time. Now sender's job is done. Sender is done with it. Is sender waiting? No. I send a message. That's it. Let him take care of it whenever he can. I don't care about it. My job is done. I'll say that my status, it's been posted. I'm good. Now let's take a look at the receive stuff. Okay, let's this is the message polar. I call message polar. I call this as message polar. I can also name this as receive message receiver. The reason I call this as a message polar is because this guy will go and poll the message. This doesn't get delivered automatically. That is message listening. Nobody is listening to this particular queue yet. That is different. Message listening is you don't have to do anything. As soon as the message comes, it gets delivered to your program. Okay, that's not what we are talking about. This is, I'm polling it. I'm going to receive it. I'll change it to, I don't want to confuse anyone. I'll say message receiver. Okay, I'm a message receiver. Again, I'm a JMS template, and I'm auto-wired. I'm listening to the same queue. In fact, yep, I need the same qualifier because I want to now I want to connect to this particular queue here called statement processing queue, and then I'll check if there are any messages. I'll just blindly read it. I'll get the message. If there are any messages, I'll read it. So I have a message. I have a method called receive message, and now JMS template has another method called receive, and then we are giving, hey, what queue are you talking about? What queue? In fact, it makes a lot of sense to call this as a statement processing queue, right? Hey, I'm listening. I'm looking for messages in this particular queue, statement processing queue, okay, which is defined here. Here, the physical name is this guy, okay. So here, I'm going to the mailbox. This is the mailbox. This is the mailbox, right? This is the mailbox. I'm going to the mailbox and get my message. I'm going to receive it. JMS template.receive. I'm giving the queue and I get the message. And this is again javax.jms.message interface. And then there are several kinds of messages, object message, text message, so many other messages. So message instance of text message. If it is a text message, then I'm typecasting to text message and I'm printing saying that message received was, I just got this message. And as soon as I receive the message, this should be gone. This should be 0 and this should be 1, dequeued, deleted. Agree? So I have a test class 2. I'll refactor this guy. Message receiver test. Okay. So I'm saying message receiver. I refactored this guy. So message receiver dot receive message. I'm just calling my own class. It's actually connecting to this guy, connecting to this mailbox, giving this name, and then asking for the messages, and it gives the message, and we are printing system.out.println. That's it. See, my class message receiver ran. Message received was, hello, it's time to process the statement for John, credit card owner. Now let's go refresh it. I got the message. We got this. We got the message. Now message enqueued is 1 and message dequeued is 0. Let's refresh it. Message enqueued. Oh, message enqueued is 1. This will be starting from the point active MQ server was started. How many messages was total enqueued, and totally how many messages were dequeued. So number of pending messages 0, number of consumers 0. Let's browse. Nothing. This mailbox is empty because it's been dequeued. There was one message here and that's been dequeued. Now you want to post one more message? This is message number 2. Now let's go check the statistics. So total message enqueued 2 from starting of the server. So total messages posted were 2, and how many were deleted? 1 deleted. So how many left? 1 left, because 1 has been dequeued. Earlier we read already. So the another one is waiting in the queue. There is 1 message in the mailbox. Let's browse it. Oh, this is the message apparently. Okay. This is message number 2. It's waiting. Let's go receive it. Let's go receive it. Message receiver test. Let's go receive it. Run as JUnit test. Message received was, this is message number 2. Ah, cool. Now let's go and refresh this guy. DQ2, we get total messages enqueued since the starting of the server was 2, and the dequeued 2. 2 have been dequeued, deleted, browse. There are no messages. Mailbox is empty. This is polling. This is good. This is really good. But what if you want to do number of consumers? Sunita's question is number of consumers should be 1 at this point, because your program ran, consumed the message, And now no one actually working on it at this point, right? There's no one. The consumer came, took the message, and then exited. This guy exited, right? That's why the number of consumers is 0. So no one is actively consuming right now. Now, message listener. This is good, but message listener is actually the fun part, right? So what is message listening? As I told you before, here, most of the times with the queues, you will poll it, you will go get the message, but with the topics, the default mechanism and the only mechanism in the case of topic is to publish it. You automatically, I'll call your message listeners. So all you have to do is you have to implement the javax.jms.message listeners on message method. So I have a message listener here, test message listener. I'm implementing message listener, and I got the on message. This on message, who will call it? It will be called automatically as soon as the message is received. Okay, and I have the message. So it's on message called. If the message is instance of text message and I'm printing the text message, that's all I'm doing. Okay. Okay, now I have to tell you something here. Traditionally, before Spring, this was one of the reasons why EJBs were used. There are 3 kinds of EJBs, right? Session beans, entity beans, and message driven beans. That message driven bean is nothing but a message listener that implements on message. That message driven bean, you deploy it in the server. As soon as the message comes, your on message will be called by your server, by your fancy WebSphere, WebLogic, by your application server. That's one of the reasons why people use EJBs. But Spring doesn't have any container. Spring doesn't have any big fat containers, no application servers or anything. Spring also provides mechanism to call this on message, to call the on message when the message is received. When the message is received on your QR topic, the on message gets called. There is a way that Spring also provided that. If you go to Spring, first I created my message listener as a Spring Bean, and here, if you look at it, message listener, whatever the bean ID, you can call it anything. Class is default message listener container. So Spring provides this container which will call the message listener that you specified, whatever the message listener that one is. You have this message listener, test message listener. As soon as the message comes on that particular topic or queue, I will call the on message. So Spring's default message listener container. Actually, there are a couple of other ways of getting this message listener containers, but this is the default way and the simplistic way. So obviously, I took the simplistic example. So I'll say MQ connection factory is good, but the MQ send queue, statement processing queue name, I'll say statement processing queue. Message listener, I'll say message listener. So these are all, you know, the Spring Bean has all of these properties, like a setter method, set connection factory. You have to give the connection factory name. You have to give the destination. What is the destination? Either it could be queue or topic, the appropriate destination. Here we are saying that, hey, can you please call my message listener, this particular message listener, as soon as the message is received on this particular queue. Okay, and then concurrent consumers I'm saying too, so it can have up to 2 concurrent consumers. So, and then we have the message listener. We looked at it. Message listener. Okay. Now this is what I'm going to do it. In message listener, what I'm doing here, in the test message listener, I'm doing, as soon as I receive the message, I'm printing it, right? And now let's do this. Using the message sender test, what I'm doing here is, I will read from the command line and I will type it. I will type here. Okay, I'll type something here. As soon as I type something here, I'm reading from the command line here. See, I'm not posting a simple message anymore. What I'm doing here is, because I want to show you that, what happens exactly in container, right? So I have this buffered reader. I'm taking the system.in. That means I'm reading from the console. I'm reading from the command line. And then loop until the word exit is typed while true. So I'll be keep getting from the command line. I'll keep getting from the command line. I'm always on the command line. Whatever you type it, I'm taking command line dot read line. Each line I will take it. This is message or line, string line. Okay, I'm taking that whole line. If that line is exit, then I'm exiting this whole application. Otherwise, I'm calling this message sender and send the message, and I'm posting to this guy. So as you keep typing here, I'll keep posting the messages into this queue. Since there is a message listener on this particular queue, what happens? The onMessage method of that particular message listener will be called automatically, and then that will print. You got what I'm saying here? Now, I'll just run this guy. I'll just keep running. I'll run while true. I'll keep running until you type exit. So, okay. So now it's listening while true, command line dot read line, but we didn't write anything. I'm just posting a message, okay? We have to observe this carefully. Messages enqueued, messages dequeued, so far 2 and 2, okay? Now I'm posting a message, test message 1. Let's refresh it immediately. So the message has been posted. The message has been posted. See the number of active consumers now 2, because we are putting while true. So we are keep listening, okay? We keep listening, and 2, the message listener. So message enqueued 3, message dequeued 3. So there are 3 messages since from the beginning, right? So what happened actually, when I typed this test message 1 and enter it, the message has been posted to the message sender.send message. So a message has been posted to this queue, but there is a listener on the other end. There is a listener on the other end that we wrote here, right? Where is that message? Test message listener. So this guy's onMessage method called, and see this one, sending the message, test message. Okay, that part is done. Now see this one, onMessage called. OnMessage called, and then we receive the message, test message 1. If you imagine these two are 2 different systems, one guy is posting to the queue. As soon as the message is posted, it called the on message on some other applications. Imagine these two different applications. Unfortunately, in this simple example, both the Java programs happen to be in the same project, but imagine them in two different systems, in two different areas, two different banks. One guy is posting, the other guy is receiving. Two different, one vendor, client. Imagine. So here we keep listening, right? One more. We got one more message, and then as soon as the message comes, then immediately the end message method was called, and then what is the message that we got here? One more, and then that has been dequeued as soon as that's been consumed. That's the behavior of a queue anyway. Make sense? The same thing works exactly for topic 2. Same thing exactly works for topic. Makes sense? You got the concept? How it works? Two different applications, messages, consuming, one guy posting a message, the other guy receiving a message. This is for queue. We can do the same thing for topic. In fact, if you want to, we can, we have a stock ticker topic already, right? We have a stock ticker topic already. So let's create a topic here. So this is a physical name, but it has to be ActiveMQ. It's not Q anymore, it's topic now. Physical name is stock ticker Q. In queues, is there a way? Let's check ActiveMQ. Okay. Hey. Hey, I love this one. This program is still running. Okay. This program is still running, and now we can you can type if you want to, but forget about sending. Okay. Let's talk about receiving. Let's talk about receiving. This program is still running. What I'm doing here is, take a look at it. What I'm doing is, since I don't have one more application to one guy is posting, the other guy is receiving, I'll post here. Send to. I'll post. Something I'll say. Message from ActiveMQ console. See this beautiful thing. On message called, received the message from ActiveMQ console. There is no distraction now. I can send one more. Second message from console again. Beautiful. On message called again. See that? As soon as a message comes into this one, your on message method is getting called. Exact same thing for topic. If you want to do it. So you have the topic here, MQ connection factory and everything same. And your message listener could be anything, and you can, in fact, you can use the same message listener. Yeah, we can change the same message listener, but all we do is stock ticker topic. Instead of saying the destination queue, we'll say stock ticker topic. Now let's go to test message listener, right? Yeah, it doesn't care whether it's a topic or queue anyway, right? It's all configuration. So anyway, let's exit out of it first. Yep, it's exited now. System.exit. Now what we'll do, message sender test. Just because it has while.true. That's the only reason I'm doing it. Okay. JUnit test. Okay. Now topic. What topic are we talking about? This one. Let's post a message. Let's broadcast something. IBM changed from $43 to $45. See this? On message call, received the message, IBM changed from 43 to 45. We have, so we have a message receiver, on message called twice. Oh, actually there is a property that's by default set to false, I believe. It's called on local. So when you post it, that itself can act as a listener. There is a, yeah, by default. So what happens is you yourself can be a listener. So if you want to take a look at that one, this is an old. This is without JMS style. So if you, behind the scenes, I wanted to show you this one finally. I'll explain why this is called twice. But behind the scenes, this kind of stuff is written by Spring. It gets the initial context. This is for JNDI. You get the topic connection factory. I mean, topic connection factory, we are giving it anyway. Create topic connection, then topic session. It creates, publisher and subscriber. And then again, it will get the topic stuff. And then session dot create publisher. And then once it gets the publisher, you can write a message. See this? Publisher dot publish you message. And then subscriber, if you want to, you can say subscriber dot, you can get the message. Subscriber dot set message listener. If you are the subscriber, you are telling who the message listener is. This, meaning this class is the message listener, meaning this is what I mean. I'm implementing Java Extra.jms.message listener. Spring took care of all of these low-level details for us. Okay? And that is why you don't have to write all of that. Yep, this is the one. By default, session dot create subscriber, topic, null and true. This third parameter is, it's called on local. By default, it's false, meaning it doesn't prevent me from receiving the messages on the channel that I opened. Don't worry about it, but that's what it is. It happened because you posted the message. But if someone else posted it, since you have the connection open, that's why it happened. So that's what it is. You got the point? So that's how, this is exactly how, this is a great architecture. This is not just fun posting and receiving stuff. And this is the whole architecture on which several discrete applications, several completely different applications are able to talk to each other. This is the fundamental architecture behind all of this. Architects, designers love it because it gives architectural flexibility between, when you are dealing with these heterogeneous systems. You may be dealing with the EDI files that have been in the company for 40 years. On one end, you are talking about the bleeding edge technology, something like a front end, client side, MVC architectures. So you can integrate all of them using this architecture. So publish, subscribe, and P2P, point to point. That's it. Thank you so much.